Okay, so we didn't finish yesterday, so this is part 2 of yesterday's lecture, basically. So we're talking about graphing square root functions. Remember, functions means you can only have one y for every x, right? So you can't have a complete parabola sideways. You can only have half of a parabola sideways for it to be a function, right? And that's what we're talking about right now. So we figured out that y is equal to the square root of x is our parent function, right? That's what it called it in the book. And I'm calling it standard root guy. Standard root guy. And as long as you remember him, you can graph these no problem. We figured out that if you have an a that's not a 1, here a is 1. Do you guys agree with me? There's a hidden 1 right there in front of the square root of x, right? So it doesn't change the value of what y is, right? But if a is not 1, if it's something else, if it's 5, you're going to multiply that 5 times whatever the square root of x is to get a y that's going to be bigger than it was before. If a is a fraction, though, like less than 1, you're going to multiply it times the y version, or times the square root of x, and you're going to get a smaller number than you would with standard root guy, right? Does that make sense? So you guys know that. So now we figured, oh, well, then we went one step further. We said y is equal to a times the square root of x, and then plus k. That k is not under the square root sign. Is that clear? It's not under the square root sign. All that does is it moves the graph up or down, right? So if that were a plus 10, I would take the y equals ax squared, and I would just move that graph up 10 and start there. And
so it's kind of your y-intercept.
Plot it. I'm sorry?
No.
Yeah, it actually is your y-intercept. K is your y-intercept, just like with y equals ax squared plus bx plus c. C is your y-intercept, always. K is your y-intercept. It's where you're, well, actually, let me just think about that for a second. That is, well, that's not totally true.
Because it doesn't.
Well, you're going to see soon, as we move into this one, then suddenly we've got something different. It's not really always your y-intercept, but it is as long as a is 1. Actually, as long as you have the square root of x, as long as it has just plain the square root of x, there's no problem. Even if a is there, that's fine. Then this will be your y-intercept. This one is what we're about to talk about today, and you'll see why it's not going to be your y-intercept.
What about the one with the k and the x minus c?
And this one, this will not be your y-intercept here. And you'll see why. Okay, so this is where, so we have covered this. We've covered everything up here. So we've covered this, we've covered this, we've covered this. These are what we're going to talk about today. And I think what we're going to do is we're going to use a t-chart for a second just to try one of these and sort of see what it does to the graph. And then once we see what it does to the graph, we are going to deduce what is an easier way to graph it, right? Kind of where things, what happens to the beginning points, right? So this is new to you, right? This is all new to you because you didn't see the video. So
I'm going to get notes.
yeah, and I want you to watch the video tonight, yesterday's video. It's important because all of this will be totally clear to you once you see that video. But I'm not going to go back and redo it. So, all right, we're doing one like this. Okay, so I'm going to keep a as 1 for now. I'm just going to make it really simple, okay? So let's say we have y is equal to the square root of x minus 3. Y is equal to the square root of x minus 3. And we're going to do a t-chart. Now, if you're going to do a t-chart, it's the x's you choose, right? You get to choose your x's. Am I right? Let me see. All right. What would be an easy
0. 3.
If I did 0, then I'd have the square root of negative 3.
So it'd be like
3.
4.
3. Why 3, Nathan? Why 3?
Because then 3 minus 3 is 0. And then
Yes. So you choose what works. Easy, right? You make the easy choices. If I had x equal to 3 here, then I'd have the square root of 0. And that's easy. The square root of 0 is 0, right? So when x is 3,
y is 0.
then y is the square root of 0, right? Which is 0. Am I losing you? I just see a few blank. Basically, the idea is, if I had standard root guy says this, right? It says 0, 0, 1, 1, 4, 2, 9, 3. You with me on that? Okay. I want to choose an x for this that makes the value 0 under the square root sign. Does that make sense? So I want under the square root sign, I want that value to be this, so that my y will be this, right? So my value here, if I choose x as 3, 3 minus 3 is 0. So then I have y is equal to the square root of 0. That's going to be 0, and that's going to give me what's here, right? Now the question is, what would x have to be for the value to be 1? 4 minus 3 would be 1, right? So I put a 4 here, and that would be the square root of 1, which is 1. And that again, the 1 corresponds to this. All I'm doing is choosing an x that will make the value under the square root sign be the x value of this, a standard root guy, right? So I now want it to be 4. I want this to be the square root of 4. So 7, right? 7 minus 3 would be 4. So I'm going to put a 7 here. All right, and then square root of 4 is 2. Okay, and I could keep going. We'll do one more. So if I want it to be 9, it would be 12, right? 12 and 3, right? So now if we graph this, this is my x, this is my y. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're going up, right? 2, 3. Okay. So it says 3, 0. So I go over 3 and I put a dot at 0. That's interesting. I didn't put my dot at 0, 0. Like a normal square root. You know, y equals square root of x, the square root guy.
So it's kind of like that where, or I guess how it moves it like left to right.
Yeah.
On the x-axis.
Yeah, so the number underneath the square root sign after the x is actually moving things somewhere. So we're going to look at that in a second. Let's finish graphing it. 4, 1. I go over 4, up 1, I put a dot. Okay, 7, 2. 4, 5, 6, 7, up 2, put a dot. And then I've got 12, up 3. 12, up 3, right about there. So there's my graph. Whoops. Anyways, you got the idea. And it keeps getting bigger. It'll look more and more straight, but I mean, it'll look more and more horizontal as you keep going. But it always is moving upwards. So it goes forever up, right? Yes?
Isn't that standard?
It is standard parabola guy. Look at this. From here, over 1, up 1, over 4, up 2, over 9, up 3. From here. Does that make sense? It's standard, not standard parabola guy, standard root guy, right? It is this, but it's moved over here. Now, how could you find that in the future? Look at that and look at this.
Oh.
Yes. So what's your conclusion?
That you, if it's the number is under the square root sign, you move it over to the right. I would say, I kind of want to say the opposite of the number.
The opposite of that number, basically, yeah.
Yeah.
Yeah. So another way to word it, you're totally right. Another way to word it, the way I usually think of it, is what would x be to make the value under the square root sign 0? Right?
Okay, yeah.
Does that make sense? To make it 0, what would it be? It would be positive 3, right? So I'm going to move it over. I'm going to take standard root guy and move him over 3 positive. And then that's going to be my new starting point. Does that make sense? Yes.
Standard root guy is a backwards version of standard parabola guy.
Exactly.
Yes.
Whoa!
Totally. Remember?
One, two.
Remember,
whoa.
it's 0, 0. It's
That's
over 1,
crazy.
up 1, over 2,
So
up
sad.
4. But it's backwards. Over 1, up 1, over 2, up 4, over 3, up 9, right? It's just backwards, right?
And
Totally
that's the
backwards.
problem.
And it makes it sideways. You think it'd make it like backwards, but it makes it sideways, you know? Right, good, awesome. So look, so immediately, now that you have this, now that you know this, what if I said, let's graph, let's use a different color, please work, red. Okay, y is equal to the square root of x plus 6.
-6.
Yeah, what would make this value under the square root sign 0? X would have to be -6, right? So I'm going to go over here, 1, 2, 3, 4, 5, 6, and I'm going to put a dot. That's it, right? Because there's nothing else over here to worry about. It's just that. Over 6, and then it's just going to be standard root guy from there. So I'm going to do over 1, up 1. Over 1, 2, 3, 4, up 2. Right? And then over 9, 4, 5, 6, 7, 8, 9, up 3. That should be a little higher. Okay? Look how fast we graph that. Right? So there's no K right now. Right? You with me? There's no K. So the K, what does the K make it do? What does the K make it do? Yes, Alex.
The K moves it like up and down.
K moves it up and down, right?
Okay.
There's no K in this. If I had put a K here, let's say I said plus 5,
So
what would I have to do? I would just have to move this up 5. 1, 2, 3, 4, 5, and put my dot here. And then I just do standard root guy. Over 1, up 1. Over 4, up 2. Over 9, up 3. Right? See what I'm saying? From here, over 1, up 1. Over 2, up, over 4, up 2. Over 9, where's 9? Up 3. And draw my graph. Done. Look how fast. We can do these, like, you can do all of this homework, like, so fast. Right? The only problem is you have to draw the graph, though. I'm not giving you the graph paper. You have to use your graph paper and draw your graph, so that takes you a little longer. All right, so another color. Let's try one more, and then I'll give you the homework. Y. We'll do this one. Y is equal to the square. Let's see. Well, let's try 2 square root of x plus 1 minus minus 10. All right? So this is a hard one, right? Not that hard, but it's a little hard. So what does that tell me?
It's down 10.
I'm going to have to go down 10 somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I know it's going to be down on this somewhere. What does this tell me? What does x have to be for this to be 0? -1. So it's going to be over here, -1. -1, right? Whatever this has to be, negative, it's got to be -1. So my starting point is right there, right?
So wait, so those
And
two
then-
numbers kind of make a vertex, don't they? Right? Like so it's like
Yeah, exactly. And then what does this 2 tell me?
that it's gonna
It's going to be, I have to multiply that times my y of my standard root guy, right?
Yeah.
So all I'm going to do now is I'm going to think, okay, my standard root guy is going to be times 2. Over 1, up 1 times 2, up 2. Over 4, 1, 2, 3, 4, up 2
4.
times 2. which is 4, right? You with me?
No.
Over. Okay, sorry. All right, let's do this slower. So, from here, I go over 1, up 1 times the 2. So I got to go up 2. Oh, wait a minute. Over 1, up 2, right there. And then from back over here, I'm going to go over 4. 1, 2, 3, 4. Up 2 times 2. So I'm going to go up 4. Right there, right?
So over 1 up 4.
And then I'm going to do over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 3 times 2, up 6. So like there. So here's my graph. You with me?
No, Gary, you lost me when you did the 4 thing. Can you do that part again?
It's higher up.
Gary, can you move for a second?
It's this number now that gets multiplied.
No, but where
The A gets multiplied
So if you
times
make the
this.
t-shirt, Leon?
Times this. So it's like this times 3 times 3
Yeah.
times 3 times 3.
Guess what
So this is 0, this is 3, this is 6, and this is 9.
Yeah, but where are you doing that from? Or from 0? Like,
Oh wait, times 2. What am I doing? Jeez, times 2. Sorry.
1 times 2 is 3.
What was I
Gary, now you
doing?
have to change your other answers.
So now all these are wrong. Jeez. All right, 2, 4, 6, right?
So, but what did you do? So when you did the one with the 4, where did you do that from?
The one with the
Like,
4.
wait,
You always start at this point.
Okay.
So I went over 1, and it's up 1, right? Because this says over 1, up 1. But it's up 1 times this 2.
Yeah.
So it's up 2. So over 1, up 2. And then it says over 4, up 2. So it's over 4, up 2 times that 2. So I got to go up 4,
Oh, okay.
right? And then it says over 9, over here, up 3 times 2, which is up 6. So I went up to 6. I went from here, 1, 2, 3, 4, 5, 6.
Yeah.
And there it is, boom. Right? You know, if you don't like that method, you're welcome to just do a T-chart, right? But that's easier. This is quicker.
I like that more than it.
So you just have to remember what it all does. So look, this has everything in it. A just makes it longer or shorter, right? This moves your point left or right, right? The H moves your point left or right. The K moves your point up and down. Clear? Right? Okay, that's it. So that's the end of the lecture. So homework.